All right, everybody. Are we good? Good to go? All right. So welcome everyone. Thank you for attending session 3A today on persistent identifiers and scholarly communication at the RDAP Summit 2024. This is a Zoom webinar. Attendees are muted and your screens are turned off. So to ask a question, please use the Q&A at the bottom of the screen. And if you forget, I'll prompt you to drop that into the Q&A. I'll keep an eye on the chat. The session runs from 12 noon to 1 o'clock Eastern Daylight Time, with the last 15 minutes being held for Q&A. This session includes 2 live presentations followed by 2 pre-recorded lightning talks. You'll be able to ask questions of presenters from both the live and the pre-recorded talks at the end of the session. Please indicate the presenter or presenters you'd like to direct your question to, and we'll save all the questions till the end of the session. After the session, please feel free to drop questions in the Zoom chat and continue the conversation in the session chat in FeedLoop. The Research Data Access and Preservation Summit organizers are committed to providing an environment where all attendees can participate fully in the program and activities without fear of harassment or discriminatory behavior of any kind. There's a code of conduct helper available during this session. This is Matt Harp. You'll see the COC in his, not byline, next to his name in Zoom. So he's identified as the code of conduct helper in FeedLoop and in Zoom, and you may direct any messages to them in FeedLoop if you need assistance. They can give you the code of conduct email address or the link to the incident report form if needed. Okay, so first we are going to hear from Anthony Dell'Orificio and Clara Pokshiva, both of whom are from the Memorial Sloan Kettering Cancer Center, on elevating the role of research data and scholarly communication. So I'm going to hand the mic over to them and take it away. Thank you.
Great. Thank you, Emily. Good job with our names, by the way. Gotta give you a challenge. So we're going to talk a little bit about an intersection point between scholarly communication and research data management. Specifically, we're interested at MSK, we're interested in not only understanding the bibliographic research output of members of our institution, but also interested in the output, the research output that is not typically captured in bibliographic catalogs, so data sets and code applications, that sort of thing. And then we're also interested in trying to figure out how to link those things to each other. And we've come up with a solution, working on solutions that work for us. So we wanted to demonstrate what some of those are as well. So a few things to sort of initial observations to get us started. Tracking institutional output, bibliographic publication output, is something that's commonly done by scholarly communication departments. It's not like a new thing that we're presenting, but it's something that we think we're expanding on. Adding in those other research outputs adds a level of complexity to this that I think is makes it a little tricky. Making it a little further tricky is that there's a many-to-many relationship between publications and data of various types that support that research, or research output that comes from core facilities and the like. Despite how tricky this is, though, we think this is an important thing to do. And I've listed out a few reasons here why we think this is important, but really, I think one of the biggest is that this gives a fuller picture of the research that our institution puts out there into the world. You may have other ideas for why this is valuable. So an easier said than done version of what does it take to make this happen? Well, first, I think you need to be able to identify the bibliographic output from your members. This can be surprisingly hard to do. There's a lot of ways to spell and misspell Memorial Sloan Kettering Cancer Center, for example. It's also hard to tell who's a member of your institution at what point they're doing their research, and especially if there are collaborations between different institutions, it can be a little bit hard to figure out which publications are really coming out of your institution. Adding in the other bibliographic sort of the non-bibliographic research output has its own challenges. You'd have to identify those pieces of data as well. The metadata in repositories can be a little messy. The schema are not always really well structured, so it can be hard to identify which of this research is actually being produced from your institution. Then you have to be able to get that metadata from both of those types of things and put them into a sort of either a common system or have them interoperable so that they can work across systems together. I can't stress enough how important PIDs are in this process. Use of authority controls, standardized metadata schema. These are all really important for making this part of it happen. And then sort of a fourth component would then be taking the different components that you now have metadata for and linking them to each other in a meaningful way. It's a little bit easier to do this retrospectively, going sort of in an ongoing sense with data reuse, publications that come out in the future. It's a little harder to track. Ultimately, what we're really looking for here is to try to add structure to systems that maybe don't have as much structure to them, metadata that's a little bit better quality metadata, augment this process in some way so that it's a little more feasible for a department to do. And then where possible, we want to automate to try to make this, functional. So because this is kind of specific to our institution, I want to just spend a minute talking about how we're structured at MSK. In our library, we do have a scholarly communication team. It's a staff of 4, and they've been doing this for many years. That's really been beneficial to us as we pursue this. They catalog bibliographic output, and they do it in an application that we brand as Synapse. It's locally hosted and maintained in-house. It's a third-party application, but I think we're kind of the sole developers of it at this point. Really, sort of to take note of is the scale that they're working on. It's tens of thousands of bibliographic citations. Newer is the research data management group. That consists of Clara and me. We've been doing this for a little over 4 years, and we have a broad set of things that we do, but one of the things that we have is a data catalog. It's based on open source code from NYU, locally hosted as well, and we contribute to the development. The scale for this, though, is like hundreds of records, and that's really been a driving point in how we chose to develop a solution here where we could sort of trigger this from our side, but not duplicate cataloging. Okay, I'm going to turn it over to Clara to talk a little bit about what our data catalog is.
Thanks, Anthony. So the data catalog is for exactly the kind of research output that we've been talking about, the stuff that's not traditionally included in bibliographic catalogs. And this is a catalog of metadata records only. It's not a repository. We don't store the actual data in the data catalog. This allows us to focus our attention on curating and enhancing metadata about the research output that we're looking at. And it sort of lets us use the data catalog as a wayfinder or a portal so that researchers can more easily find restrictions on access, information about the data that they're looking for, and make it easier for them to connect their publications to their other research output. As we've been talking about, it's very important for a catalog to be using a standardized schema, and we do. And that sort of helps us potentially track reuse, publications, funding, other kinds of information that are attached to the data sets that we're cataloging. And because this is not a repository, we can sort of sidestep concerns about PHI exposure. We don't have to worry about that because we're not hosting the actual data. So I just wanted to give you guys a little bit of a closer look at a singular catalog record. This is a data set produced by MSK authors. You can see that we do have a local PID that makes it easier for us to keep track of the individual metadata records. We also have a description of the data set, and because a lot of this data deals with very specialized medical information, we are not trained in all of those types of data that we're cataloging, so we do use descriptions of the data set written by those who know it the best, which are, of course, the researchers who produced it. We also employ authority control from MESH for our subject cataloging. This makes it easy to search for data sets based on relevant search terms, and helps us categorize the data that we're cataloging. And we also have an integration with MSK's sort of in-house oncological classification system, which is OncoTree. This is particularly useful because a lot of researchers use OncoTree in their own work, so we can just pull the words out of their descriptions of the data or their publications to make it easy to search and classify. Of course, we want to provide researchers with an easy link to the dataset repositories where the data is actually hosted. We'll also always include the PID or accession number if the repository uses one. And then most importantly, we do have an integration with Synapse, which Anthony will tell you more about in a moment. But we link to the publication record in Synapse, which is the metadata associated with the publication rather than the data.
And we can have multiple publication links there so that if a data set is used by multiple, is identified in multiple publications, we can have multiple links. This is the sort of end result on the other side, on the Synapse side. This is our bibliographic catalog. And the end result is this little related data sets button, which is links back to the data catalog and actually includes a list of all data sets which are relevant and linked to this paper. So I'm going to explain just a little bit on how we get there. I don't want to spend too much time on the technical side, but I do want to give you a little bit of an idea on under the hood what we did here. So for a data cataloger, they might identify a link between a data set and a publication. In Synapse, they would identify the work ID, that's the PID in Synapse. They would then enter that work ID into the data catalog. And because there is a public API in Synapse, we can grab the citation data directly from that work ID. We have a script that manipulates that data into a citation. That citation gets reviewed by a cataloger. Once approved, it links that citation to the Synapse record and stores the two PIDs for the data catalog record and the Synapse record into a table, which is presented via an open API from our data catalog. Then we have a script that runs on the Synapse side, which creates a conditional related data sets button that collates all of the instances where that Synapse record is identified as having data sets. It's fairly simple and straightforward, but it really, really relies on accurate data. Yeah. Let Clara talk a little bit about how we get that data.
So this is just sort of a look at what this looks like from the cataloging end. One of the big sort of issues that we have is identifying data sets that are associated with our institution. MSK deposits data sort of across a broad variety of data set repositories, and each one requires a slightly different search method for identifying institutionally affiliated data. You can see this example here is the search string that we've built to search GEO for MSK data. And if you look at some of like the text of these submitter institute search terms, there's a lot of variety. This is user submitted metadata. So when researchers are kind of entering the metadata for their research into the repository, they might make keystroke errors. They might sort of use a slightly different variation of our institution name than we would anticipate. And so this sort of requires building these very long, complex search strings that will capture those inconsistencies, because we don't want someone to not be tracked or not be accounted for just because they've misspelled Memorial Sloan Cancer Center. Obviously, that can be very time consuming to refine through these search strings and sort of sift through these results. You can also identify data sets via their publications. So if you find a data set or a publication that has a data availability statement, rather than going to the repository first, you can search the accession numbers in the data repository. So you're not looking for institutionally affiliated data, you're looking for a particular data set. If you find a repository record that does not link to a publication, you can also search the repository accession number in PubMed or PMC. And because it's in the data availability statement, you can also identify the associated publication via that method. Obviously, this really heavily relies on researchers specifying accession numbers and repositories in their data availability statements. As we all know, that's not always the case. So we want to be sure that researchers continue writing sort of like these detailed availability statements so that we can continue connecting their data. And then this step is sort of simple. We just want to make sure that because we're linking to the Synapse record and not to PMC or PubMed, we want to be sure that we find the metadata record for that publication in Synapse. You can see here, there's the PubMed record, there's the Synapse record. And then finally, this is the API that Anthony just walked you through. We want to find the Synapse ID from the Synapse page. And this is sort of what that citation process looks like on the back end. It's very simple. All you have to do is enter the ID, press the spacebar, and the API will autofill the Synapse metadata in the correctly formatted citation. Once you hit submit, you'll get that associated publication link on the data catalog record. And then finally, here's that related datasets button again. The Synapse record will update with that immediately. So there's no kind of wait to connect the two systems. And it does make that connection between the data and the publication explicit in both systems. It's a bidirectional link. Generating the associated publication citation in the data catalog will also generate the related datasets button in Synapse. There's no need to recatalog. And because the Synapse team is very busy and works with a high volume of record, it's great that our cataloging team can just link both systems together without the need for recataloging or duplicating effort. And then finally, of course, as we've sort of learned throughout this process, it's important to reduce keystroke error wherever you can. And that kind of auto-generated citation and bidirectional linking makes that possible.
Great. So, I mean, this is kind of functional for us right now. I think there's sort of growth concerns about this, and where do we go from here? It's still a lot of work, even though we've sort of cut down one half of the cataloging side. So where we see this going, we'd like to see more automation in the process of discovering data sets. That ongoing tracking is a really tricky one, something that I'd still like to tackle a little bit more. We need to understand the usage of this system through analytics, and then very similar to our keynote presentation, Itachi. This is, if we want to expand this beyond MSK and we want this to be something that's valuable elsewhere, we need to be talking with publishers, repositories, and standards organizations to get that metadata built into the system and to have it programmatically accessible. I think that's ultimately good data is going to be the solution to this problem. So that's where we are. Hopefully this is helpful, and we look forward to taking any questions that you might have later. Thank you.
All right, thank you both. That was so cool. And I can't wait to hear more in the Q&A. So now we're going to hear from Andrew Johnson from the University of Colorado Boulder on his presentation, Community-Based Interoperability for Research Facility and Instrument Persistent Identifiers, Enabling Connection Throughout the Data Ecosystem. All right, so I'll hand it over to you, Andrew.
Great, thanks so much. Just 1 second. All right, sorry about that. Took me a second there. Can everybody see my slides okay?
Yep, you're good.
Awesome. Okay. Get my windows set up here. Thank you for the introduction. And yeah, I'm Andrew Johnson from the University of Colorado Boulder Libraries and our Center for Research Data and Digital Scholarship. Talking to you from soon to be very snowy Boulder, Colorado. I think we're supposed to get maybe up to 20 inches of snow in the next 24 hours. So bracing for that currently, but glad to be virtually here at RDAP with you all today. And the topic of the presentation here is on an NSF funded project that we have to explore community needs, barriers, and incentives for adopting persistent identifiers, or PIDs, for research facilities and instrumentation. And we're thinking of that really broadly so far in our project. So basically, any research infrastructure that's used to collect and acquire data. We haven't gotten into kind of precise definitions for the various pieces of that yet, but that might come later. And as I think, as we've seen over the last decade plus, PIDs have been an important part of the sort of connective tissue of open science in general, helping to link research data, other research outputs, other entities involved with research, all kind of together. And as you can tell from our title, we think that incorporating PIDs for research instruments and facilities into this larger open science picture is important for a variety of reasons that I'll kind of go into later in the presentation. But especially we feel that this work needs to be done in a way that coordinates across a variety of different communities. So that was the need, that was the basis for a collaborative award that we received from NSF as part of the FAIR Open Science Research Coordination Network Program, or the FAIROS RCN program, which is a really amazing cohort of projects focused on different aspects of open science. For our project, NCAR is the lead institution, with Matt Marinick as the lead PI, and the other awarded institutions were Florida State University, led by Renee and Julian, and obviously CU Boulder, where my colleagues and I are located. Our colleague, Claudius Mondoma, was also the director of the core facilities here at CU Boulder when we first received this award. And interestingly, he was also at Florida State prior to that. So he's kind of got a lot of connections to the institutions involved here. But after we received the award, he moved on to a similar role at Stanford. But thankfully, he's been able to stay involved with the project as a co-PI. So that's how Stanford has now become involved with this project as well. As a research coordination network project, our main goals all focus on more of the kind of community, social, and organizational aspects of this topic, rather than things like data collection or technical implementations. So we're really focused on engaging with as many people, organizations, and groups like that who have interest in this space as we can throughout our project. Through those connections, we're trying to identify a wide range of use cases for adoption of PIDs for instruments and facilities. And then we're moving from those use cases to sharing expertise and guidance, and then ultimately to recommendations and lessons learned targeted to the multiple communities involved, which include researchers, instrument and facility operators across a wide range of disciplines, infrastructure providers, publishers, and of course, data and information professionals, which is why we're excited to be talking to you all here at RDAP.
Andrew?
Yeah.
Sorry to interrupt. Quick question. Would
Sure.
it be possible to adjust your slide size, that we have some
Oh, I'm sorry.
difficulty seeing it? No, that's okay. Sorry to interrupt.
Yeah. Let me see.
Thank you.
I can't tell what you all can see on my end. So let me just.
I think it's that this screen size seems kind of narrow, so I'm not sure if it's the way you're sharing it or
Yeah, let me see. Let me see if I can like go to full screen. Is that better? It's getting better, better.
Yeah,
better?
that's
It is for
better.
me. Yeah. Okay,
Right.
good. Great. Thank you.
Sorry
Sorry to
about that.
interrupt.
So sorry.
No, you're good.
Great. Well, good that happened there, because I think this is a slide where it might be helpful to have a bigger view. So this picture here is to give a bit of a high level overview of PIDs across networked or open science. The symbols and placement of the nodes and connections here aren't really that important. It's more kind of just like a graphical representation of all the different aspects of the research ecosystem that need to be connected for purposes of things like discovery, reproducibility, giving credit to all the various people involved in research, including facility and instrument developers and operators, who are obviously especially important for the purposes of our project. You can see the kind of variety of just some of the different types of PIDs involved in the research ecosystem. And interestingly, when we started looking into the existing landscape of PID use for instruments and facilities, we found that there are maybe more different approaches and systems being used for those than for some of the other parts of the kind of open science picture, like where there's been, a lot of kind of agreement on ORCID use for individual people, DOIs for data sets, and so on. We saw this even on our own campuses or at our own institutions. So this is an example of PIDs, in this case, research resource identifiers, or RRIDs, that our colleague Claudius Mondoma helped implement at Stanford. And he also did similar work when he was here at CU Boulder, where he registered RRIDs at the kind of facility level for the core facilities across our campus. And if I'm not sure if you're able to read the small print here, but this picture also kind of gives you a sense of some of the types of facilities we're talking about. So at Stanford, there's, you can just see a few examples here of the electron and ion microscopy facility, soft and hybrid materials facility, nano shared facilities, X-ray and surface analysis facilities. At NCAR, which is also here in Boulder, Colorado, if you're not familiar with NCAR, our colleagues over there have registered DOIs for a variety of different instruments and facilities, including even research aircraft. They have aircraft that conducts kind of scientific campaigns. And then there's also an example here of an integrated surface flux system that they've registered a DOI for at the Earth Observing Laboratory. Likewise, at CU Boulder, we've registered DOIs for our research computing infrastructure, including the Alpine supercomputing cluster shown here. And as I mentioned, our core facilities group also uses RRIDs. So even just on our campus, we have multiple PID systems in use for instruments and facilities. So this was kind of one of those scenarios that led us to looking into this community-based approach for connecting all of these approaches. So our Pharos RCN project is a 3-year project, and we're currently in the early stages of the second year. So we thought this was good timing to kind of share out what we've already seen after our first full year of activities, which included, of course, things like setting up a website and other logistical parts of the project, doing a lot of legwork to identify people, projects, resources that we should engage with throughout the project, which also included outreach at several conferences and various disciplinary and stakeholder communities. And we're obviously continuing to do that in year 2 with this conference. We'll be at the Year of Open Science culminating conference next week, and also IASIS later this spring. So we might see some of you at those venues as well. But beyond conferences, we're also doing some kind of targeted focus groups and other discussions. And some of these have included with other NSF projects, including the other Pharos RCN projects, the CI Compass Fair Data Working Group. We've also done focus groups with some facility operators on our own campuses, and some more discipline-specific groups as well. And we're going to continue to do more of these throughout the rest of the project too. And then finally, kind of all these activities in year 1 sort of fed into and then culminated in a 3-day in-person workshop that we held here in Boulder in the fall last September. So this workshop was the first of 3 of these in-person workshops that we have planned for the project. And we're hoping that these kind of build upon one another. So this first one was really aimed at identifying use cases around motivations for and barriers to adopting PIDs for facilities and instruments. We brought together 35 participants who we identified mostly through the networks that we'd been conducting outreach with. And we ended up with a really good range of kind of geographic coverage across the country, a range of people in different types of roles and across a variety of research disciplines. At the workshop, we had a number of presentations about different use cases, and we also had some structured breakout discussions on the main topics of the workshop. And then all of this fed into a report that we developed and was just recently published as an NCAR technical note in their repository. It's linked from the slides and then also from our project website, of course. And then, so kind of the next group of slides, which I'm going to try to go through super fast in the interest of time, are the main takeaways from our workshop report. And we structured these as especially kind of in this first workshop, more as like observations rather than recommendations. And we tried to pair these with next steps for either our project or the kind of communities involved, or both. So this first one is, maybe obvious, but we felt still important to say, which is that there does seem to be agreement that there's a need for PIDs in the facilities and instrumentation space to enable reproducibility, to help users understand the provenance of data from these instruments, and importantly, to help facility and instrument providers get credit for their contributions to research, which are very significant, of course. And we think that everyone involved in this space has a responsibility to encourage adoption and use of these PIDs. I've mentioned this briefly already, but we confirmed at the workshop that there are multiple PID systems and approaches already in use, including RRIDs and DOIs. And we really need to better understand how and why each system is being used. What are the benefits? Are there disciplinary differences, things like that? Adoption is a really critical piece of this, obviously. And since it largely falls on instrument providers to be assigning these PIDs, we really need low barrier solutions for adoption, as well as ensuring interoperability, more kind of technical interoperability among different PID systems, so that the choice of system doesn't hinder the value of adoption. And people definitely want clear guidance on this aspect. The metadata underlying PIDs, and then questions of where these instrument and facility PIDs might fit into other metadata. For example, the metadata accompanying data sets. These questions come up a lot, and there's already really great work being done in this space out of the PID-INST group, which came out of the Research Data Alliance. So we need to be sure to kind of leverage that work going forward. This was a really interesting one that came up quite a bit, both at the workshop and in many of our conversations with various groups. But basically, really quickly, there start to be questions of, the appropriate level at which to assign the PID for an instrument or a facility or both. These can get really complicated, as can, also questions about how instruments change over time when components are added or other changes take place. When does it become a new instrument, and therefore a new PID needs to be assigned. And decisions and best practices about this might vary quite a bit across disciplines and various communities. And then also we found possibly across the motivations for assigning PIDs in the first place. So for example, whether that's done primarily for the purposes of reproducibility or more for tracking attribution and credit of facilities, you might see kind of different use cases there. Another thing that we heard a lot from facility operators in particular is that many of those people are very limited in terms of their resources and bandwidth, which ironically is also why they're so interested in the possibility of using PIDs to better track use and citation of their facilities, because presumably that might then lead to justifying additional resources. But this lack of bandwidth does create a barrier for adoption of these PID systems in the first place. And people are definitely looking for guidance on how to engage with PIDs, given those resource constraints. Which kind of feeds directly into this next issue, which is once you have PIDs in place, how do you convince users of facilities and instruments to actually cite the PIDs in their articles or their data set metadata, other places that might be relevant? And particularly, how do you make the case that that's of value to them to do that? Oops. And again, kind of going right into the next one, one way to address that issue of value is, to create new value through incentives for users to cite PIDs and also for facility operators to adopt them in the first place. We've discussed a number of different possible incentives that might need to be implemented at different places and by different actors in the research ecosystem. And that's something we're definitely going to explore further in the next stages of the project as well. So that was a very quick overview of kind of the are the main observations and next steps we've seen so far for the project. And we wanted to kind of end by asking you all here at RDAP how this resonates with your work, as data professionals. We've had some connections come up already, at the workshop in our discussions in terms of how PIDs for facilities and instruments might intersect with data curation and repository work versus, via like inclusion in README files for data set documentation or other kind of repository metadata. We've also heard some ideas about how this might come up in consultations with researchers and possibly even people who operate facilities at your various institutions. But we would be very curious to hear any and all feedback on those ideas or any other thoughts from this community as well on our project in general. In addition to sharing any of those thoughts right now, if you have a chance or if you have questions, you can also contact us at any time via our website or reach out to me directly. That would be totally fine. And also we'll be having our second workshop this summer if you're interested in diving deeper into this topic. So we'll have more information about that coming soon. It'd be great to have anybody from this community join in on that. And yeah, thank you again for the opportunity to talk to you all about our project today, and happy to answer questions later if there are any.
Great. Thank you, Andrew. We have some really great questions in the Q&A, so I'm looking forward to diving into some of those. But first, we get to hear the pre-recorded lightning talks. So the first is from Raini Suliman from the University College London and Brin, Indonesia, whose lightning talk is on fostering interoperability, a proposed concept in aligning Cinta ID and ORCID for integrating research data repositories and data services. And then right after that, we will have our second lightning talk from Ali Kirsten from Auburn University, who will be speaking on no field, no problem, enriching IR metadata via the DOI registrar. And so let's, I'll stop and we'll start the lightning talks. Thank you.
Hello, good afternoon, everyone. My name is Madirin Sulaiman, and I'm from UCL UK and Brain Indonesia. Today, I want to share a little bit about my proposed concept in promoting the interoperability in aligning Cinta ID and ORCID for integrated research data and repositories and data services. A little about me, I'm a PhD student at UCL, and I'm still active as a research data librarian in Indonesia National Research Institute. Therefore, I label myself as a data champion due to my work in advocating open science and fair data. To begin and to give you some context, in this presentation, I want to highlight interoperability within FAIR principle, while also highlighting that it should be accessible with the help of identifier as a standardized communication protocol, especially within repositories. Therefore, the proposed synchronization mechanism between Cinta and ORCID has the potential to greatly enhance the depth and quality of research data repositories. The Cinta ID, which is part of Cinta, Science and Technology Index, an Indonesian web-based research information system like GRIS or RIN, and the ORCID, a globally recognized identifier that stands for Open Researcher and Contributor ID, in fact, can effectively complement each other. As you can see, Cinta ID covers research profiles with its own assigned number. It shows the research output trends per individual, and it is validated by personal and institutional level. Numerous best practices for the interoperability of name identifiers have been established by international and professional networks, including Google Scholars and others. However, I would like to emphasize the national or local ones, such as Vitman ID in India, which is a component of IRIN's Indian Research Information Network System. Both Vitman ID and Cinta ID promote the researcher's expertise by integrating populated data into one hub. Their products and services are similar. In this case, Vitman ID through IRINS that is managed by InflipNet uses the ORCID integration in their DSpace queries to populate those data for researchers' profiles page. It would be great if Indonesia could implement a single workflow to Sinta and Sinta ID, taking inspiration from Orchid TSP program, which offers various integration options for systems like RIS. Well, based on this graph, the Directorate of Research Information Systems has identified a variety of RIS use cases in numerous countries, some of which are centralized and others of which are federated. In addition, according to Orchid Stats, numerous researchers in Indonesia have incorporated not only Sinta ID but also Orchid into their research profiles. This further can be seen from the Sinta stats, which include a dedicated dashboard that the public may use to gain insight into national indicators for publication, benchmarking, expertise, and analysis in Indonesian context. Therefore, integrating Orchid and Sinta ID will be an important step toward fostering the interoperability of Indonesia's research ecosystem with the global landscape. We can also access data from local repositories in Indonesia like Rama and others, as well as from national repositories like Green Dataverse, or work together with grassroots communities like RGA. Both are integrated to common indexers as well as like Google's Scholar. So whether at the schema, record, or repository level, this could help in the enrichment of researchers' profiles and insights. Research outputs and research data landscape as a whole would be improved with the integration of this element, which would make research outputs more fair. Data librarian will undoubtedly be pivotal to the success of this interoperability initiative, since they will be greatly affected by their ability to offer data services. If the research data ecosystem were better integrated and developed, data librarians would be more efficient in carrying out their duties as managers, curators, and providers of access to research data. The best thing they can do is advocate for research profiles that are both nationally and internationally focused, so they will have an easier time connecting researchers to their associated publications and institutions, and also streamlining data collection if the ID profiles are synchronized. The use of validation procedures is also essential for improving data quality and, by extension, information trustworthiness. To sum up, data librarians could be able to provide more effective and efficient data services if Sinta ID and Orchid are integrated. It could help the wider research community by enhancing the discoverability and accessibility of research data and its output. So I think that's all. Thank you, and looking forward to our discussion later.
Hello, my name's Ali Kirsten. I manage the institutional repository at Auburn University, and today I want to tell you about our project to improve the metadata that we report to the research ecosystem through our DOI registrar datasite. Like many institutional repositories, Aurora is built on DSpace, and since 2020, we have configured that DSpace repository to register DOIs through datasite. DSpace is somewhat limited in the fields that it can represent compared to DataCite, and especially with the relationships that we'd like to represent, for instance, between a data set and its linked articles, or researchers and their identifiers like ORCID IDs or their institutions. And so we've been looking into ways to recurate and improve the existing metadata. One way to do that is to change the way that we register those DOIs through DataCite. So our current workflow is our users submit a record through Aurora, and I then review, or somebody else would review, their deposit to ensure that it's ready to be published. And once that deposit is approved, it immediately becomes public on the web, and the metadata is automatically pushed to DataCite. Overnight, it will then receive a DOI. But the problem with this workflow is that even though it ensures that every object will get a DOI and that all of the metadata will match, we're leaving a lot out of what DataCite is actually able to do with its metadata schema and the things that it can represent. So what we are considering doing is to decouple the workflow so that Aurora and DataCite actually operate separately, as if there was a wall between them, and all of the processes will then become manual. This will allow us to update the information reported through the DOIs, the metadata that goes to the open web, completely independently, whether we want to add more metadata initially or update the metadata at a later date. We can do both of those things without disturbing what's already in the repository or having anything overwrite. So far, we've been working with an undergrad assistant, and together we have reviewed the DOIs that have already been registered to see what their metadata looks like in Aurora, what the metadata looks like in DataCite, and the student has been working hard to enrich those metadata records in a test instance such that it won't actually affect our production system. You can experiment with adding fields, looking up the additional metadata such as ORCID IDs, perhaps funding sources, linked articles. As we looked at the 700 or so DOIs that we've registered so far, we found that about 50 of them are data sets, which is our sort of high priority items that we're looking for to enrich those records. And that means it shouldn't get too out of hand to go back and improve them manually. We did find that ORCID IDs are not being matched to authors because, again, DSpace is not able to represent that relationship the way that the DataCite metadata schema is. Our rights statements, even though they exist in Aurora, are not getting through to DataCite at all. So according to DataCite, none of our deposits have any rights statements. That's a problem. We also discovered that our data sets are missing their data files, and that is because we had a reservation system that still required the DOIs to go live. Once we decouple these systems, we will be able to assign draft DOIs, which is something our users very much want. We still need to hammer out how we're going to represent linked article relationships. The next step is decouple the Aurora workflow from the DataCite metadata workflow. And then we will go and take those test instance records where we have enriched the metadata and bring that information over into the live metadata registry through DataCite. At the same time, we'll look into how we want to have our users request DOIs and how to improve our processes so that all of this goes more smoothly and we can continue to improve as we move forward. Thank you for listening to me today, and I welcome any questions you may have.
Okay, great, thank you. So we have a ton of questions, and so we'll dive right in. The first, okay, great, thank you, Andrew. And thank you to all of our presenters and the audience for participating in this session. And we'll hope to see you at our next session, which is poster 1. And there will be a Zoom link for the next session, which you can find in the Feedloop Sessions tab. And so thank you all again. We really enjoyed hearing from you.